Let us solve a few more problems from the chapter of trigonometry under measurement of angles. Find the radius of a circle in which the central angle of 45 degree intercepts an arc of length 33 centimeter. So if we have a circle here, and we have to find what? We have to find the radius. We have to find the radius in which the central angle of 45 degree intercepts an arc of length 33 centimeter. Arc length is 33 centimeter and it intercepts an angle. This is an angle of 45 degree at the center. So here we have to find the radius. Arc length L is 33. So we know the formula. We know formula theta is equal to L by R, where theta is in radian, the angle equal to arc length by radius. Here we have L, we are given arc length equal to 33 centimeter, and R we don't know, we have to find R. And theta also we are given, which is 45 degree, but it has to be in radian, so we convert it to radian. 45 degree becomes 45 into pi by 180 radian. So this is cancel with 9, 9 5s are 920, 5 1 is 5, 5 4. So our theta is pi by 4 radian. So directly we apply the formula theta equal to L by R. So R will be equal to L by theta. So we just put the values. L equal to 33 degree and this is pi by 4. So 4 comes in the numerator, 33, the value of pi is 22 by 7. Again 7 comes in the numerator and there is 4. So easily we can cancel 11 into 3, 11, 2, 2 1 is 2, 2 2s are 4. So it is 7 2 14, 14 into 3 is 14 3s are 42 centimeter. So the radius is 42 centimeter. So this is one problem. Another one, if the arcs of the same length of two circles subtend angle 70 degree, 75 degree and 120 degree at the center, find the ratio of their radius. So we have here two circles. We have two circles, and for the same arc length, that means if you take same arc lengths, here AB and CD, these two are of same length. If AB is L, CD must be L as well. So for the first circle, it subtends an angle of 75 degree, and the second, it subtends an angle of 120 degree. So what we have to find is the ratio of their radii. Let the radius of the first one be R1 and the second one be R2. So let R1 and R2 be the two radii. So we know the formula theta equal to L by R. So for the first one, if theta is for the first circle, if theta is, the angle is theta 1, and for the second one theta 2, then what will be the ratio of theta 1 by theta 2? It will be L by R1. R1 for the first circle, R1 radius is R1, and for the second circle radius is R2. Now we know that the arc length is the same for both, so we can cancel this. So what we have now? So R2 equal to R1. So what we have to find here is the ratio of the radii, that is R2 is to R1 or R1 is to R2. So here theta 1 and theta 2. Theta 1 is, for the first circle it is 75 degree, and for the second circle it is 120 degree. or this theta must be in radian, we have already said. So in order to convert this into radian, we can write it like this. Anyway, it will get cancelled, so no need of so many calculations. So this will be, if we cancel, 5 1 is 5 and 5 5s are 25. This will be 5 2s are 10 and 5 4. So this, if we cancel again with 3 5s are 3 8. So 3 5s are 3 8. So we have 5 by 8. The ratio R2 by R1 is 5 by 8. Or we can write R1 by R2 is, taking the reciprocal, it will be 8 by 5. So therefore the required ratio is 8:5. So this is the required ratio. So clearly here we see that the first circle, the ratio of the radii of the first is to the second circle is 8:5. So clearly we see that the first circle is having a larger ratio. The first circle is the bigger one and the second circle is a smaller circle. Let us see another question, the third one. A wheel makes 180 revolutions in 1 minute. Through how many radians does it turn in 1 second? So we know what is a wheel. A wheel is of circular shape. It's a circle. It makes 180 revolutions in 1 minute. We know in 1 minute, in one revolution, the angle covered is 360 degree, or in radian we write it as 2 pi radian. So in one revolution, if it turns one time, it makes an angle of 360 or 2 pi radian. So 180 revolutions, so it is turning 180 times in 1 minute. In 1 minute time, it can make revolution of 180 radians. 180. So through how many radians does it turn in 1 second? So if in 1 minute it turns 180 revolution, in 1 second how many radians will it make? So radians means angle. We must know that it is angle. So here let us write it. So here number of revolutions made in 1 minute, made by the wheel in 1 minute is equal to 180, or in 1 minute consists of 60 seconds. 60 second equal to, in 60 second number of revolution made is 180. So from here we get, for 1 second, in 1 second number of revolution made will be, using the unitary method, 180 by 60. So if we cancel this, 6 into 3, so this is 3. That means for in 1 second how many revolutions are made? 3 revolution. Let's write it. In 1 second number of revolutions made is equal to 3. Also in 1 revolution the wheel turns an angle of 2 pi radian. Now we need angle in radian, not in degree, so we write in 1 revolution the wheel turns an angle of 360 degree, or in radian 2 pi. So in 1 second how many revolution is made? 3 revolution. So in 3 revolution how many angle will it turn? 3 into 2 pi. Therefore in 1 second the wheel turns an angle of 3 into 2 pi, which is 6 pi radian. So in 1 second number of revolution made is 3, and in 1 revolution angle turned is 2 pi radians. So in 3 revolution it is 6 pi radians. So this is the answer.